And the importance of this I already highlighted in the previous talk. Again, the 10 characteristics of discontinuities. Please practice it again. Orientation, spacing, persistence, roughness, wall strength, infill, seepage condition, joint set, block size. I missed one actually. 10. Please practice it by yourself. I will give you a question. Please describe the 10 characteristics of discontinuities. I force you to remember this. Okay? 10 characteristics. Again. Do you still remember? I teach you about 2.1. Start from orientation, spacing, persistence, roughness, wall strength, aperture, filling, seepage, number of sets, joint sets, and block size. Okay? Right now, I want to talk more about orientation. I already tell you, for the orientation, we will have 2 characteristics to be described. The first one will be the orientation of a plane. The other will be a vector. Okay? Vector will be a line. And the orientation of discontinuities will be a plane or a line. Normal vector or tip vector. Okay? So how can we describe this? I already showed you this. You can show this via Ross diagram, but you can only show it, the orientation, the strike of the plane, or the tip angle of the plane. It will be difficult to show it graphically, especially for a plane. And I will show you how to show the distribution of the orientation of discontinuities, like this. I will show you. You can try to use the graph circle to represent one plane. So every single curve here represent one plane. If you have a lot of planes, then you will draw a distribution like this. Then nobody can understand this. So usually we will try to use the normal vector like this to show the distribution of the orientation of the joint orientation. Okay? It will be more easier when you reduce the dimension from a plane to a vector, or from a vector to a single point. If you can reduce the dimension, then it will be much easier for you to show the orientation graphically. Okay? It's kind of visualization. Of course, with the advance of technology, maybe in the near future, you don't really need to use this. You will have the so-called VR. And maybe if engineers want to know the discontinuity structures subsurface, you will have a VR. And the engineers will go into there and see a lot of things, and you will understand the whole structures of rock mass. But right now, we don't really have this kind of tools to help you. But maybe in the near future, you will have this. Right now, the most important communication tools between engineers, rock engineers, and engineering geologists will be this. And on the other hand, engineers itself, sometimes they need to use the staring net to analyze some engineering problem, engineering issues, like rock slope failure, or Sometimes we call it the block theory, to analyze the stability of the rock blocks around a tunnel. When you talk about this, you need to have a three-dimensional thinking and use these tools to solve your problem or to solve your question. Okay, so how to reduce the dimension? We're trying to use this projection to reduce the dimension. We have a lot of way to make the projection of the Earth. When we're trying to produce a map, we're trying to use the projection. Okay? And we have a lot of projection way. This will, we call it equal area, and we call this equal angle. But please don't worry this too much. For some textbook, for some geologists, they usually try to use this equal area. What is the difference between these two? When you make the projection, you surely will have some distortion problem. Okay? So these two kind of projection, you will have a different distortion issue. But according to a textbook read by Hook and Bray, he said some geologists tell him he insists to use this, otherwise the results will be distorted. But according to Hook and Bray, he said, no matter this or no matter this, it will be not influence the engineering problem too many. So don't worry. For engineers, we frequently use the equal angle projection. That will be this one. Okay. So how this projection produce? I will going back. This projection, equal angle projection, you will find two line sets. One is we call it 这是经线，对不对？经线怎么讲 ？How to say that? We have a longitude and altitude, right? I'm not pretty sure. Do you know what I mean? For Earth, you will have this to divide the Earth, and you will have this to divide the Earth. So for the projection, you will have a line like this, and you will have curves like this. For all of the curves in this, we call it the great circle. Please remember, we call this great circle. All of this, we call it small circle. Understand? I will like to teach you the semi-spherical projection from the basic theory, but not trying to teach you how to draw the plane or draw a vector. Because if you learn how to draw a plane or vector alone, you will know how to do it when you take this class and doing the homework. Then you will forget how to doing this when you graduate. But if you teach you the theory behind the method, you cannot forget, because you know the theory, you understand, so you never forget. Okay? I ever told students, when I teach the students how to draw a geological map, or how to read a geological map. All of the engineers, you need to have the ability to read a geological map, including the plane view or geological cross-sections. When I was the undergraduate students, my teachers teach me how to read the geological map and give me a lot of guidelines, like V-rules. If you have a geological map, have V-shaped curves, it means the bedding plane dip into the downstream, or the bedding plane dip into the upstream, or the dip angle larger than the slope, or the angle of the slope, or something. I never remember this. When I graduate, I take a class in the master. My professor teach me how to draw a geological map. And I know the theory, how to draw the geological map. Then I can read the geological map. Because you know how this map was produced. For engineers, you don't really need to draw a geological map by yourself. But you need to learn how to read the geological map. So you need to learn how to draw the geological map. But you don't really need to be the expert to produce the geological map. It will be the task, it will be the work for geologists. You don't really need to do this. But it is not to say you don't need to understand it. Okay? We have a lot of problems occurred in Taiwan or all around the world. Actually, yesterday I have a very nice discussion with a very famous researchers all around the world. We have dinner together last night, and we talk about the geological model. So I believe what I'm talking to you is a worldwide problem or worldwide issue. Engineers don't really understand geology, even a little bit. So you will make terrible mistake if you don't know geology. Okay, back to this. I will tell you first how the great circle produced and how the small circle produced. Because all of the drawing, we were trying to well use the great circle and small circle. If you don't know what is the meaning of the great circle and small circle, then you don't have any chance to understand how this method apply. Very quick, I will start from the great circle. We trying to make the projection. Why I need to like this? Because I need to relax first. Please imagine you have a ball, like an earth. Okay, you have a ball, and we trying to put everything and project to the horizontal plane of that ball. Okay, understand? Please imagine you have a light on the top of the ball. Okay? And if you have a plane passing through the center of the ball, then this plane will intersect with the ball to produce a circle. Understand? 了解吗？你有一个球，我如果要是有一个平面穿过球的中心，那这样子的话，这个平面就会跟这个球交出一个圆。Understand? Foreigner students, can you understand? The so-called projection, we were trying to project this circle to the horizontal plane. Okay? How to make the projection? We were talking about two possible projection ways. The first one will be the upper spherical projection. The other will be the lower spherical projection. To me, or in engineering practice, we usually try to use the lower part. Okay? So I will only talk about this circle intersect with half of the circle below the horizontal plane. We will project it to the horizontal plane. How to project? Please imagine you have a light on the top of the ball. And the light, if you put the ray for the light and connect it to the circle, half circle. Can you understand? You have a circle like this, right? It will be the lower part. And you have a light on the top of the circle. You have a semi lower part circle, and you have a ray connect all of the points along the circle. And all of the ray will intersect with the horizontal plane, right? Then all of the intersection point will be the great circle. Understand? When you saw this, you will feel very terrible. But I don't really. I draw this when I was the master student by myself. It would be my note when I learn something, and I make a note like this, trying to explain something. Okay, I already explained this. If you have light here, and this will be the intersection circle in the lower part, and you connect the light, you will have a ray to connect the circle. Then you will have intersection curves here. Okay? This we call it gray circle. If we put this geometry here, then you will have an arc. It will be an arc of a circle, right? You will have an arc here. And you will have a triangle in the horizontal plane, and you will have a triangle in the vertical plane. So we start from the vertical plane. Can you imagine this? Can you imagine what is this? What is this? This will be the cross section. So this will be the plane. If I cut the cross section perpendicular to the stripe of the plane, this will be the stripe of the plane, right? If you cut a cross section perpendicular to the stripe, you will have this figure. And this will be the dip angle. And this will be the true dip of that plane. Because this cross section was cutting through a plane perpendicular to the stripe. Understand? You have a plane like this, and I cut the plane here. Then you will have the true dip. You will have the dip angle. Then this will be beta. Okay. Then you can calculate. This will be 90 minus beta, right? If this is 90 minus beta, you will have a 45 minus beta divided by 2. We call it 圆周角 and 圆心角. You know this? You learned this from high school, right? This angle will be twice of this angle. I don't know how to explain this in English, but we learned this from maybe senior high school or junior high school, maybe junior high school. 国中的人就学，圆心角圆周角关系。Okay, if you know this angle, then you will have this angle. This angle equals to 45 plus beta divided by 2, because this and this adding together will equal to 90. And you can have this. Because this is vertical, so you can get this. This will be beta. So this angle will equal to this angle. Then I push this plane down. Understand? It will be vertical, right? I push it down. Then you will have another plane view like this. I push it down. This equals to beta, then this will be equals to beta. Okay? If this is equals to beta and this equals to r, then the distance between the center to the center of this arc will be r times tangent beta. It's only geometry, so don't worry. If you know the radius of this arc, then you can draw this arc. 你只要知道一个旋的半径，你就可以画出这个旋。你只要知道它的圆心跟半径，对不对 ？Understand? So, if you change beta, you will have a different arc. So, let me tell you something. This, Professor C.T. Lee, in our institute, he drew this 40 years ago using computer. He is a geologist. Because he knows what these are. So for engineers, it's very simple and very easy. If you told me you cannot understand this, I don't believe. If you can enter National Central University and you told me you cannot draw this, I don't believe. Okay? Please imagine, if you have a flat plane like this, then you will have a smaller beta, correct? Then, like this, you will have a you will have a line or ray to contact here. Then you will have an intersection point here. The great circle will have a smaller radius. If you have a more gentle plane like this, you will have an intersection point here. And you will have an even smaller radius of this arc. Understand? How about a vertical plane? If you have a vertical plane this, and the beta equals to 90, where is the intersection point? The intersection point will be here. Then you will have a straight line. Understand? Let's go back to here. If you have a plane you have a ball like this, and you have a plane in north-south direction, okay, with the inclined surface. Then you will intersect the ball here and project it to the horizontal plane. You will have an arc like this. With increasing dip angle, this arc will gradually from here to here to here, finally to a vertical line. If you decrease the inclined angle, you have a plane, right? You cut the ball here, the arc here. If you have a more gentle, you will cut the ball here. More gentle, cut the ball here. Project to the surface, you will gradually have a great circle to here, to here, to here, to here, to here, and finally to here. Please think about if you have a horizontal plane, what will be the results? If you have a horizontal plane, then you will have an outside circle. How this great circle produce? They produce this using beta equals to 0, beta equals to 2 degree, beta equals to 4 degree, 6 degree, 8 degree, 10 degree. Then you can get a set of all of those curves, those arcs. So right now you can imagine what is those great circle are. Actually, all the great circle will be the projection of a plane with given dip angle. Understand? If I tell you there is a plane, the stripe is in a north-south direction, and the dip angle equals to 60 degrees. And this plane dipping to the west. Can you draw this? It will be quite simple, right? Dip to the west. So you need to use the great circle here. And the 30 degree. 0, 2, 4, 6, 8, 10. 20, 30. Then you along this trace, you can draw an arc. Then you will have the projection of that plane. Understand? I will not teach you the steps. I will teach you the idea behind this. Then you will never forget. Oh, 4 minutes left. How about a plane in orientation not equal to north and the south? Says if you have a plane in the east-west stripe, how to draw it? And 30 degree dipping to the north, how to draw it? It will be very simple. You will put the transparent paper about this and then rotate 90 degrees and draw it and then rotate it back. Correct? I will not tell you how to rotate. Rotate this counterclockwise 30 degrees or something. You will never remember. You just know what do you have and you just know what do you want to do. Then you will have the results. You don't really need to remember any steps. Correct? Let's talk about a little bit related to the small circle. What is small circle? Small circle will be the projection of the intersection curves project to the horizontal plane. What intersection curves? Please imagine you have a cone. Do you know cone? Do you see? It is sorry. Last year we lose the game. We lose the Japan. Baseball, right? You don't care about this? No any response. Okay. For the professional baseball game, my daughter and my son have something. 加油, 加油, right? It will be a typical cone. So, if you put the cone in the north direction, you will have a cone, right? And the cone, the tip of the cone will be in the center of the ball. And the cone will intersect the ball with a curve. And you project, you give a light here, and keep the ray to the curves. And all of the ray will intersect with the horizontal plane. Then you will have curves. These curves will be the small circle. Maybe go back to this. Please imagine you have a cone direct to the north direction. And the axis of the cone, I don't really have a cone, so I don't know how to make it. The cone, the axis of the cone will be in the north direction and in the horizontal plane. And this cone will intersect the ball like this. Okay? Like this. And if you project it, like this, yes, like this. If you project this to the horizontal plane, then you will have arc again. You will have arc again. And this series of small circles will be the opening of the cone. If you have a cone with a smaller angle, then you will have the small circle here. Increasing angle, you will have a larger and a larger small circle. Please remember one important thing. What is a definition of a cone surface? What is the definition of cone surface? 我们定义一个 cone 的表面。It will be a surface where the angle of the surface will have an equal angle in the axis of the cone. Cone 的表面是一个什么样子的一个组成 ？Cone 是什么？其实就是它的轴 ，the axis of the cone to the angle of this axis to the surface of the cone will have an equal angle. Okay? So you will have the equal angle from here to here, 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 and from here to here. And that will be the same idea here. Okay? You have a cone, and the cone will intersect with the ball here. And you have light here. And the ray for the light connect with the intersection curves. And this ray will intersect with the horizontal plane here. This will be the small circle. Again, I don't really have time. So from the horizontal plane, you will have the result like this. So horizontal plane, this will be gamma and this will be gamma. It's because of the definition of cone. Okay? If you transfer it into vertical plane, you can understand this plane will have the same angle between this vector and the horizontal and the axis. And this gamma can project to the vertical plane like this, and project to the horizontal plane like this. According to the geometry for this and for this, you can define the center of the small circle and define the radius of the small circle. I don't really go into detail about how to derive this, how to become this, because this will be a very simple geometry. If you have a three-dimensional thinking, it will be very, very easy. If you have the center of the small circle and the radius, you can draw the small circle with different gamma. So that will be the same. You have an equation, right? And you increase the gamma from 2 degrees, 4 degrees, 6 degrees, 8 degrees, and 10 degrees. 10 degrees, 20 degrees, 30 degrees. Okay, and finally, you will have 90 degrees. What does that mean for a cone with 90 degrees? That will be a plane. Cone, 对不对？你从0度开始，一条线，0度、2度、4度、6度、8度、10度、40度、60度、80度、90度， then that will be a plane. Okay, so this will be a cone with the angle equals to 90 degrees. So every single point here shows you the degree in the horizontal plane. Rest part of this lecture can be learned from my material online. Please read this. And as I told you, I will go through this fast. And lecture 2.3 for the next Thursday. Next Friday, you need to write the homework for lecture 2.2 and 2.3. I already mentioned this several times, and I have the evidence. I already taped this. Okay? Please do not tell me next Friday you don't know how to write a homework. You can have some question or problem. We can discuss. But I cannot teach you from the very beginning and teach you every step to write a homework. You can imagine it will be impossible. So if you don't do this, you will feel very painful next Friday, unless you know how to write a homework. If you want to know how to write a homework, you need to read the material in advance. Please also remember, today I give you a homework, right? You need to turn the homework to me next Friday. If you did not turn the homework to me next Friday, I will not accept any late homework. Okay? That will be a deal. I already tell this in the very beginning. And when you enter the classroom, please put your homework on the front desk. Okay, that's all. Thank you. This shows you again the projection. If you have an intersection point here, and you will project to the horizontal plane here, this will be the projection. Okay, it will be the equal angle projection. And the grass circle, it will be a projection like this. You can find there are a lot of grass circle in the starry net. Every single grass circle means a plane intersect with the ball and project to the horizontal plane. And you can determine the center of this arc and the radius of this arc via the different tip angle. Here will be the tip angle. If you have a tip angle, different tip angle, then you will have a different radius and you will have a different center of the circle. You will have a different arc. Then you can draw the great circle with different tip angle. So you need to know the meaning of the great circle. For a small circle, it will be an intersection arc between the ball and the cone. The cone will be a surface where I have the identical angle to the axis of the cone. If we put the axis of the cone in the horizontal direction, then you will intersect with the ball here. If we project it to horizontal plane, then you will have the small circle here. Let me show you here. This will be a small circle with different gamma. Gamma will be the angle between the axis of the cone to the surface of the cone. And this will be the intersection curve project to horizontal plane. The same for every single arc. You will have a different center of the circle and the radius of the circle. If you have a different gamma, you will have a different arc. So the small circle will be a series of the projection curves for the cone intersect with the ball with different angle to the axis of the cone. Understand? So that will be the equal angle projection. We call it the staring net projection sometimes. So I already showed you the meaning of great circle and the meaning of small circle. So that's practice. And tomorrow you need to draw some plane or some vector or trying to solve some question. You will sit here to solve the homework. I will show you some example. So the first example, I want you to draw a plane with the strike equals to north 30 degrees to the east. You know strike? Strike will be the intersection line of a plane to the horizontal plane. And this plane dip to the southeast 60 degrees. How to draw this plane? So this plane will be a great circle, correct? Can you draw the great circle directly here? It will be a little bit difficult. But it will be easy for you to draw a great circle with north to south direction. And the dip angle equals to 60 degrees. Correct? 你现在要画一个大圆，你画南北向，然后倾斜60度，倾斜向东，倾斜向西都很好画，直接描就好了，对不对 You can draw a line here 60 degrees. We'll start from here 10, 20, 30, 40, 50, 60. And you will draw the great circle along these curves. It will be easy. How about north to the east 30 degrees? It will be also easy. You will put a transparency paper on the staring net like I did. Okay? And you will put the north on the transparency paper like this, and you will sketch a circle along the boundary of the staring net. Then where is the north to the east 30 degrees? Are you still remember what is small circle? Small circle will be a series of intersection of a core to the ball and project to the horizontal surface, correct? What is the small circle? Small circle will be the angle between certain directions. So you have north directions. Certain angles to the north, you can count small circle. Correct? So 30 degrees to a small circle. Where? 10, 20, 30. You simply rotate. You put the north to the east 30 degrees. If you want, you can draw a straight line. Okay? Then you will try to rotate the transparency paper counterclockwise. It's not because you learn you need to rotate it counterclockwise and you need to remember it all the time. No. You are not trying to remember this. You need to know what you want to do. What do you want to do? You want to well use the great circle. So how you rotate it? Of course, you will rotate it like this. Right? Then you can well use the great circle. Which one should you draw? You should draw a great circle like this or draw a great circle like this. Because it's deep to the east-south. So it should in this direction. So you should draw a plane here. How can you draw the plane here? Again, 10, 20, 30, 10, 20, 30, 40, 50, 60. Then you will draw a plane along this arc. This will be a strike, correct? And you will draw a plane like this. And you rotate it back. This will be the answer. Is it easy? 这样有没有人不会画？画一个平面很容易，对不对？ For the national examination, for the professional geotechnical engineers or the engineering geologists, you always have this kind of question to ask the students to draw a plane with certain strike in the deep angle. But usually not too many students can answer this kind of question. I don't know why. There are a lot of advanced technology, not 3D technology, advanced question for you to answer. Sometimes it will be not quite difficult, but a little bit difficult than this. If you cannot answer the question like the difficult one, I can understand. But for the national examination, if the question asks you to draw a great circle with the strike equals to 30 degrees to the east and the dip to the east to south 60 degrees, I don't know why the student cannot answer. Can you tell me? Do you know how to draw this now? It will be easy, right? I can give you roughly some example and please tell me the strike and dip roughly. Please read it. What should be the strike and dip of this first circle? What is the plane? Roughly. Please read it. So it will be north to the west, roughly 70 degrees. And dip to the southwest direction with a dip angle equals to, I think it will be 60 or 70. Okay? If I give you a question like this, please draw a plane or a fold where the orientation of the plane of the fold equals to north to the west 60 degrees and dip to the west south 30 degrees. So roughly 60 degrees. It will be roughly here, right? So this will be roughly the strike. Dip to the west south 30 degrees. I would draw a plane like this. But difficult, this kind of question for you, smart students. What difficult on this? I don't know. Okay, I will give you some other example. I give you two planes. The first one will be north to the east 30 degrees and dip to the east south 60 degrees. You already plotted it. And I give you another plane here. North 45 degrees to the west. So it will be roughly the strike like this, right? Dip to the north east. Dip to the northeast, so you need to dip to this direction. With 45 degrees, it's roughly like this. So right now you have two planes. I gave you two planes. Do you know which better? If you have a single plane, usually, if you have a dayline, usually you will have some plane better along the plane, and you will have sliding like this. Okay, you will have a plane bearing. How about two intersection plane? If you have a two plane like this, the rock wedge will sliding down along the intersection line. Correct? We call it wedge bearing of a rock surface. Okay, so if you have two planes and the rock wedge fell, please tell me the vector of this wedge sliding down. The wedge will sliding down along the intersection line, right? So please tell me the move direction of this block. That means I want you to tell me what is the intersection line or the vector of the intersection line. Can you read it? Where is the intersection line of this vector? It will be very simple, right? Where? The intersection line will be here. What is the trend and punch of this intersection line? I already tell you, if you have a plane, if you project to the steering net, you will have arc. If you have a vector and you project to the steering net, you will have a point. Here, I show you the point here. Can you read the trend and the punch of this vector? I will not tell you the procedures. Step 1, step 2, step 3, step 4. No, you cannot remember this. But you need to know what you want to do. If you want to read the trend and plunge, what should you do? Please ask yourself, but not ask me, Professor, what is the steps? 1, 2, 3, 4. Please tell me what he wants to do. Maybe we want to have the train first. Do you still remember train? If you have a vector and you project the vector to a horizontal plane, this will be the train. And this will be the plunge. Right? So right now you want to know the train. Where is the train? The train should be the intersection line between this center to here. Right? Am I right? 这样子有问题吗？什么是 train? You have a vector here. Let's say, if you have a vector here, what is the train of this vector? North direction, correct? If you have a vector here, it means you will have a plunge other than 0. If you have a train, if you have the projection here, it means you have a horizontal vector with the train on the north direction. How about here? If you have a vector here, it means you have a vector with train in the north direction. And the plunge roughly equals to 45 degrees. If you have a point here, it means you have a vector, the train equals to north direction, and you have a plunge roughly equals to maybe 75, something like that. Okay. Right now you have a vector here. How about the train? Do you have any difficulties on this? Please give me a smile or knock your head, and I can understand you know this without any difficulties. You simply draw. You simply rotate in this direction or rotate in that direction. That will be okay. You simply want to use the straight line. I can really put these two curves right here, but I already did my best. Okay? So you need to put this point on this straight line. Help you to draw a line like this. Okay? This will be the train of the vector. What is the plunge? You will try to use this to calculate the plunge. Correct? From here, 10, 20, 30, it's roughly like 40. I don't really carefully count it, but you can count it by yourself. Right? You can count the plunge here. The plunge roughly equals to 42. And you will mark the train and rotate it back. The angle between the north direction to the plunge, you can calculate. It will be north to the east 10, north to the east 20, north to the east 30, 40, 50, maybe 60, 62. It will be the trend. Any questions on this? 有问题吗？有问题的现在问我。So what is the intersection line of these two planes? It will be the trend equals to 42 degrees with a plunge equals to 62. That means that rock block will sliding down along this vector. Okay? I already mentioned to you. How can you draw a normal vector of this plane? Please think about where will be the normal. I think it will be roughly here. It will be roughly here. Can you understand? Do you know where is the deep direction of this plane? Where is the deep direction? Do you still remember deep direction? You have a plane. You have infinite numbers of vectors. But you have only one vector have the largest deep angle. The largest plunge, sorry. And this direction will be the deep direction. So where is the deep direction of this plane? It will be here. Okay? What is the normal vector? Normal vector will have 90 degrees to the deep direction, perpendicular to each other. This will be the deep direction, and this will be the normal vector. So, where is the pole or the normal vector of the plane? It will be roughly here. And counting 90 degrees. So how to count the 90 degrees? You need to have the help from the great circle, right? Incline angle 90 degrees. So you simply rotate it back to the north-south direction. And counting 90 degrees from here. 2, 4, 6, 8, 10. 90 degrees. And you can count 90 degrees from here to here. You will have a 90 degree. And you will rotate it back. If you rotate it back, where is the normal vector? The normal vector will roughly here. If you rotate it back. Okay? If you rotate it back, the normal vector will be roughly here. Understand? So this will be the normal vector of a plane. If you have a plane like this, then here will be your normal vector. You will show the normal vector instead of showing the great circle if you have a lot. Understand? The final question to you. You have a two planes. Okay? Please tell me the angle between these two planes. You can understand? You have two angles. One angle is this direction and then another angle here. So 锐角钝角度 that's the 90 degree and larger than 90 degree. But the summation of these two angles will be 180. Okay? How to do this? How to measure the angle between two planes? How to solve this question mathematically? How? You have two planes. The angle between these two planes will be the angle between these two normal. You will dot these two angles, the two vectors. And that will be the result, will be the projection. That will be the cosine theta. Then you can solve this. 对不对？两个法定向量累积了，累积了一个结果，取 up cosine。Okay, if you want to determine the angle between two planes, the same you were trying to get the normal first. And you were trying to put these two normal vectors on the same gray circle. Put on the same gray circle. And count in the small circle. Small circle will be the angle, right, between any directions. So if you put this normal on a single plane and calculate the angle, that will be the answer. Is it okay for you? 你首先让这两个向量，你可以得到两个向量，我们要求这两个向量的夹角。首先你得到这两个向量，然后让这两个向量共面，让它共面了以后数小圆，小圆就是它们的夹角。各位还记得小圆的意义吗？为什么要跟你们介绍小圆跟大圆的意义？目的就在这里啊！你要知道它是什么，然后你就知道你怎么用它，而不是每一次叫你求一个问题的时候，你要去记得它的程序。你要去记得它的顺序，那就不对了，因为你很自然而然的你知道你该做什么事，而去做那件事，而不是记得它的顺序。Understand? So you have two planes, and you can get two normal. Right now, these two normal are not put on the same plane. This will be in this gray circle, and this will be in this gray circle. How to make these two vectors on the same plane? How? You need to rotate until these 2 points falling into a single gray circle. Then they will be on the same plane. Okay? I don't really have the answer. Anyway. Rotate in this direction a little bit. They will move to like this. And falling down to the same gray circle. And we will counting how many small circles here. That will be the angle between these two vectors. Because you know the meaning of the small circle, right? 每一个 small circle 就是一组 cone 跟大圆相交出来的线投影到水平面上，每一组小圆都是。所以这一组小圆跟这一组小圆夹2度。This small circle have a 2-degree difference with this small circle. Have a 4 degree to this small circle. So if you rotate it, one is here and the other is here. What is the angle between these two vectors? You simply calculate the small circle. Understand? 这种东西就是什么？就是你会了就会了，你不会就不会，你一辈子都不会。那你要问我说，我会这个东西要干嘛？我也不知道。但是 sometimes 你就是因为你会这个事情，你跟人家不一样。就是有人永远都不会，那就看你要不要会而已啊。So please do not ask, what is the benefit for me to know this? Actually, this will be the basic knowledge for a rock engineer, for engineers for rock mechanics, for rock engineering. Okay. This will be the similar things. You have a gray circle here, and you have another gray circle here, and you have a normal, and you have a normal. Then you can have the angle between two normal, and the angle between these two normal will be the angle between these two planes. Okay. This will be your homework too. You need to write here tomorrow. Okay? I hope you can start to write this homework today. Try to write this homework. Okay? If you have any questions, you can discuss with me tomorrow. But if you're sitting here knowing nothing, you will feel painful, and I will feel painful too, because I don't know how to teach you. Okay? This will be the homework. You need to turn it to me tomorrow. Alright? And you will try to use the equation to solve this question. I already showed you how to solve this via equation. Right? You can try to use this. I already tell you, this will be strike. Why this is strike? Because this is horizontal plane. And you have a plane intersect with horizontal plane. This will be strike. Right now you have the strike, and you will have an angle between this plane to the strike. Then you can calculate the true dip from this apparent dip. This will be apparent dip. It's not really a cross-section perpendicular to the strike, right? If this plane fully perpendicular to the strike, then the intersection line will give you the true dip. But it is not, so they give you the apparent dip. I gave you the orientation of this and the orientation of strike. Of course, you can calculate the true dip via this equation, using this equation. What I want you to do, please solve this question again using theory net. We can solve it graphically. So all this, I want you to familiar with theory net. Okay? Any question? Please do remember to print out the stereo net and prepare 4 transparent papers by yourself. I have some difficulties to find a transparent paper. I have some, but not many enough. So I cannot give all of you. So please prepare the transparent paper. 明天请带的至少4张。如果你觉得你会画错，那就多带几张。And you need to print out the theory net by yourself. Understand? Maybe you want to have a ruler of 圆规. Or maybe you can draw by hand. You don't really need 圆规. Okay. Any questions? Please. 啊，在教科书里。你明天要来写吗？不用吧。
我回去先看一下。
对啊，应该不用写了。Okay. I will quickly go through the rest of the PowerPoint. 哎，我刚刚这里有录吗？ For the site investigation, you usually have the results like this, but it will be a little bit difficult for you to recognize the results. But please see this. This will be sampling line. Sampling line will be a vector. I already tell you what is scan line, right? And they have a 3 vector. One here, and one here. This will be 3 sampling line. As you may see, these 3 sampling line perpendicular to each other roughly. Why they need to doing so? They want to reduce the sampling bias. Okay? So if you have the 3 directional scan line, if you have a 3 scan line perpendicular to each other, then the sampling bias can be minimized. Okay, if you have the roughly equal sample number, then the sampling bias can be minimized. Okay, so that would be one of the way to show the size of the discontinuities here. So he trying to use different size of the pores to show the different size of the discontinuities. And he trying to use 2 symbols, one circle and the other square, to show the joints and the bedding plane. So you can try to use this kind of idea to show some different discontinuities on the stereo net. I already mentioned the scan line to you, but I will not ask you to write this homework. Okay, so tomorrow you don't really need to answer this. I already tell you the sampling bias. Right now I want to let you know how to make the correction of the sampling bias. Before it, I will tell you how to draw the contours of the discontinuities density on the stereo net. So it will be a little bit difficult to read this plot, but in general you will know there is a normal vector concentrated here. Can you read the orientation of this plane? Please read this for me. If you have a form here. What is the stripe? Northeast. Maybe 60 degrees actually. But these will be certain, right? So if the normal vector here, you will have a gray circle roughly here. So it would be north to the east, roughly 60 degrees, and deep to the northwest, roughly 30 degrees. This will be the normal vector, right? So it's roughly, the prime is roughly equal to 60. So the deep angle of the plane will roughly equal to 30. The angle between these two will 90. If you add them together, it will be 90. So 60 here, 30 here. Okay. So how to draw a contours line for the site investigation results? We were trying to draw a contours line within this range you have say 20%. Here 30%, and here, for example, 50% of the discontinuities falling into this range. That will be the idea of the contours of the density. If you have a higher density, it means you have a more pores falling into this range. How to do this? The idea, we're using a moving window and to calculate how many pores falls into this window, and you will have the numbers. If you have a total number, then you will have the density. So you can write it down, the numbers on each window. Then you can draw the contours now. Because each window you have a number. How can you draw a contours line for topography? You are trying to measure the height at the different location. Then you can interpolate it. Then you will have the contours line. That will be the same idea. Each window you will write down a number of the density, and you can draw a contours line. Can you understand? 每一个视窗，你把它分割成，比如说100个小视窗，你就可以去计算那100小视窗里头，它的不连续面占比有多高。把100个小视窗，你就会写下100个占比。你有100个占比，你就有100个 number，100个 number 你就可以画等高线，对不对 ？So I want to tell you how to make the sampling bias correction. It shows you here. Every single measurement, you will times a weighting factor equals to 1 divided by cosine delta. Cosine delta, the delta will be the angle between the scan line and the orientation of that plane. Understand? I already tell you. If you have a scan line in this, and every single discontinuities perpendicular to this scan line will be easily to be found. But if you have a scan line like this, and all of the discontinuities parallel to the scan line, you will extremely difficult to find it. So this will be the amplification factor. If you move parallel to the scan line, then you will have a larger weighting function. You will amplify the weighting of that measurement. Understand? 你会放大一些不容易被 sample 到的不连续面。But this will be proposed by Tazagi, okay? The weighting function should be less than 10. So the maximum correction will be 10. So every single measurement, it will be not really the density of the discontinuities. You need to times the weighting function, not weighting function, but the weighting number, to amplify the numbers you measured. Then you use the amplified value to make your contours. It means you make the correction of the sampling bias. If you have a straight scan line perpendicular to each other, maybe you don't really need to make this correction. But if you don't really have this, you have only one scan line, please remember you need to adjust your measurement. Otherwise, you will have a bias the sampling results. Okay? As I already mentioned to you, if you want to representatively measurement results, maybe you want to have a 100 to 1000 measurement. It depends on the complexity of your geological setting. More compressed, you need to have more measurement data to make your statistically meaningful. Okay? Okay, I will skip this, and actually I showed you here, if you want to calculate the mean vector mathematically, you can do it like this. Okay? It will be not really difficult. If you go through this, you will find it is very simple. If you know the vector analysis, then it will be very simple. Okay. For example, if you have a 3 vector, 1, 0, 0, 0, 1, 0, 0, 0, 0, then you can use this to calculate the average vector of this. It will be 1 divided by root square of 3 plus 1 divided by root square 3 plus 1 divided by root square 3. Can you understand? The average of these 3 vectors. It means the average of this 3 vector will be here. So this mathematically form can be easily used for your calculation. You can write Excel. Okay? If you measure in a field, and if you have a 100 measurement, you can use this to calculate the mean vector. If your measurements are the same groups. If it is not the same group, please do not use this to make the average. Okay? Like I tell you, if you have a 3 joint sets like this, and you average this will be meaningless. It's neither this, neither this, neither this. And this shows you the variability of the discontinuity you measure, and you can also calculate the standard deviation using this. We call it kappa. Kappa shows the variability of the normal vector to the mean value. If you have a larger variability, it means you will have a larger standard deviation, and you will have a very large uncertainty for your engineering design. Usually you have this kind of problems. Okay, so normally you will have the measurement like this. Sometimes you will have a measurement like this. What does this mean? You will have a concentrate normal vector here, and the other normal vector of the discontinuities distributed mainly along a graph circle. And this graph circle will roughly be, this normal vector will be roughly the normal of this graph circle. What does it mean? I already show you, if you have a bedding plane like this, this could be the orientation of the bedding plane. Usually, we will find there are 4 joint sets on this rods. The first one will be this. What is this? Deep joints. Okay. The strike of this discontinuity, the strike of these joints parallel to the deep direction of this bedding plane. So we call it deep joints. And you will have another like this. We call it strike joints. Okay? It's because of bending. If you have folded rocks, then you usually have discontinuities like this. And this will be the discontinuities parallel to the maximum principal stress. I already showed you, right? And usually you will have 2 like this. We call it conjugate joints. So you will have a deep joint, strike joint, conjugate joints. Please tell me, what is the common of those discontinuities? 这些不连续面有什么共同特性？什么？在什么？我们在前面。 在同一个面方向 something like that, but not really 在同一个面上。We can speak it in more specific. All of these four discontinuities, the normal, were falling into the plane of the bedding plane. Where is the normal? The normal vector were falling on the bedding plane. How about this? The vector were falling on the bedding plane. This, the same. This plane, all these planes are perpendicular to the bedding plane. So the normal vector of this plane were falling into the bedding plane. It means all of the plane, the normal vector, the core of these discontinuities were falling into the great circle of this. All of the discontinuities were falling into the great circle of the bedding plane. Understand? This will be the last slides for this talk. So I will not really teach you how to make the analysis of rock slope failure. But as you may see, if you have the discontinuity like this, and here is the fault, so you have two homogeneous zone. In this side of the joints, you will have one homogeneous zone, and on this side of the fault, you will have another. So the pattern of the discontinuities could be different for two sides, and you have a different cutting surface. This will be the so-called open cut. In many countries, we have the open cut to get some resources, like coal or gold or coopers. So you will have an open cut. So this will be the contours. So this cutting will face to the south. This cutting will face to the north. Understand? So according to the steering net analysis, the failure mode will be totally different. For here, you will have a plane failure. Here, you will have a wedge failure. And here, you will have a toppling failure. It's only related to the orientation of the discontinuities and the slope faces. If you don't know this, it is impossible for you to doing the analysis for the rock slope failure. It is impossible. You cannot understand. Never. You never can understand this. Unless you know the steering net analysis. Okay? I will skip this.